guys, it's me again. 11.5. We're going to find volumes of prisms and cylinders today. We're going to find formula for density, and then we're going to use some volumes and prisms, the volumes of prisms and cylinders, and some applications. So hopefully everybody's got their notes up and running while you're watching this video so you can do some examples with me. We're going to first start with the volume of a prism. So we know what the area of a two-dimensional solid is. We've found the areas of circles, we found the areas of polygons. Now we're going to take that to a three-dimension and find the volume. So basically we're taking the area and then we're going to multiply it by the height. So our basic formula for the volume of a prism is the area of the base, which stands for the big B, times the height. So depending upon what the shape of the base of the prism is, this formula is going to change. If it's a square, we would use side squared. If it's a rectangle, you do length times width. So this part right here fluctuates depending on what the shape of the prism that you're actually finding is. The height's always the same. It's just how tall is the prism that you're finding, how tall is that. So on our first example, and I'm going to do my best to draw this picture, we have this shape. Let me try and get it. Oh, this is not going to be good. Ish. Just work with me here. So we have a 6 and an 8 and then a 7. Okay, so obviously the area or the shape of the base is a triangle. So our volume, we're going to use the area of a triangle, which is 1/2 base times height. So that's just for the bottom shape. And then we're going to multiply it times the height of the whole prism. So this part right here, we have 1/2 the length of the base of my triangle, which we can use right here. We know the base is going to be perpendicular to the height of the triangle. So the base is 8, the height of the triangle is 6, and then we're going to multiply that whole thing by the height of the whole prism, which is 7. So again, we get our calculators out, we multiply it all together. I'm going to take 8 times 6, we'll divide that by 2. So that gives me the area of the base, which is 24. And then if I multiply that times 7, I have a volume for this prism of 168. So we found the volume of a triangular prism. Now the next example is a little bit easier. We've got a prism that is rectangular on the base. So again, let me try and draw it up here. It's not going to be the best. So there's my rectangular prism. Okay, let's fill in the sides. The sides have a length of 10 and 4 and a height of 12. So again, let's start with our formula. V is equal to B times H. B is going to be the area of the base. Well, the base in this shape is a rectangle. So the area of the rectangle is length times width. And then we multiply that times the height of the whole prism. So the length is 10. The width is 4. And the height of the whole prism is 12. Okay, we're going to multiply all those all together. So we get 10 times 4 is 40. 40 times 12 would be 480. If we had units on there, we would put them. These are going to be, because it is a volume, you would have cubic units for your volume. So those are prisms, okay? The other type of thing we're going to find the volume of today are cylinders. Cylinders have a specific base. It never changes. A cylinder is always going to have a circular base. So this is the formula for the volume of a prism. The B could change depending upon what the shape of the base is. On a cylinder, since it's a circle, our formula is always going to be pi r squared times h, because the base of the cylinder is always going to be a circle. Now, if we have this, this is not going to be good. So the first example on your notes is a half of a cylinder. Okay, it had a height of 15 and a diameter of 4 in this case. Now, our formula doesn't have diameters in it, it has radiuses. So, when we put this into our formula, we need to figure out what the radius is. Radius is half of my diameter. So my radius is going to be 2. So when we put this into our formula, I have pi times 2 squared times my height, which my height of my cylinder is 15. We would plug that all in, multiply it. 2 squared is 4. 4 times 15 is going to be 60. So if we leave it as an exact answer, we would leave it in terms of pi. If we want the approximation, we would multiply those two together. 60 pi is 188.49, and we have our value for our volume. Cubic units. The next example, we don't have to split it in half. However, the shape is not at a complete right angle. It is called an oblique cylinder. So an oblique cylinder is one that's at a slant, but we don't do anything any different when we're finding the volume of it. So we're given this, and we know that that is the right angle. The height that we want is the distance that makes the right angle with the base, the bottom of it. So in our picture we had the height of 10 yards. We have a radius of 6 yards. So my formula, V is equal to pi r squared times h. We're given the radius already. We don't have to do anything to adjust that. So we put in our 6. We put in our 10 for our height. And then all we have to do is multiply it out. 6 squared is 36. 10 stays the 10. We multiply that together. 36 times 10 is going to be 360 times pi. And then we have our units of cubic yards. Again, if your clever assignment asks you for the approximation, it'll tell you where to round it to. We just multiply the 360 times the pi, and we get 1130.97 cubic yards. Okay, so that's how we find our volume of a cylinder. Now, if we have similar, I'm way ahead of myself. Density. Density is what we're going to do next. So density formula, density is the mass divided by the volume. It tells you how much stuff you have for a given size of the figure that you're using. In our example here, it says a cylindrical container with a radius of 8 centimeters is filled to a height of 10 centimeters with sulfuric acid. The density of sulfuric acid is 1.84 grams per cubic centimeter. What is the mass of the sulfuric acid to the nearest gram? So, we know our formula. D is equal to M times V. So let's fill in what we know. We know we have a cylindrical container. So the volume for a cylinder is is going to be pi r squared times h. Okay? It's filled to a height of 10 centimeters with the sulfuric acid. We're given the density is 1.84 grams. So 1.84 equals, we're trying to find the mass. So m is going to stay as m. We have pi times, does it tell us the radius? Yes, the radius is 8. And it's filled to a height of 10 centimeters. So we can put this over 1, we can cross multiply these, and we will be able to solve for m. So m is going to equal 1.84 times pi times 8 squared times 10. So we multiply that all out. 1.84 times 8 squared times 10, and I get 1,158.4 pi units. If I multiply that out, it is 3639.22. There's our mass in grams. Okay, so there's density. The very last thing we're going to talk about is similar solids. So because we have volumes are cubic inches or cubic units. Scale factors, when we have similar solids, we can take the ratio of one figure to another, and it's just going to equal our scale factor cubed because we're dealing with volumes. Our notes were not very good there. The picture went away. So I'm going to put one up. Everybody draw this with me on your notes. So let's say, follow me over here. I have one cylinder that has a radius of 3, and it has a volume of 100 cubic units. Okay? And I have another cylinder that is smaller, and it has a radius of 2, and I want to find the volume of that cylinder. So my similar figures tells me that if I take the volume, the ratio of the volume, so if I take 100 over x, because I'm trying to find the volume of the smaller, so I have bigger over smaller, it would equal the ratio of parts that we know, either radiuses or we could either use heights, but that's going to equal that cubed. So I want to put the big radius over the small radius, and I'm going to cube that because we're dealing with volumes. So I cube both parts here. I have 100 over x equals 3 cubed is 27, 2 cubed is 8, and then I can cross multiply this. 100 times 8 is 800. 27 times x is 27x. We divide that by 27, and we get our calculator. 800 divided by 27 is 29.63. And that's going to give you the volume of the smaller figure. Okay, that's how we use similar figures to find missing volumes. So there we have our 11.5 notes. Again, if you have questions, please email me or contact me somehow. Miss you guys.